In this section, we're going to dive into exponential functions. Now, there's a couple ways you can tell you have an exponential function. One, when you look at the equation, whatever you have going on, you could have a number here, but it's always going to have an x in the exponent. So that right there is what makes it an exponential function. The x is in the exponent. Now, another thing you can do is if you're looking at the table, which we talk about in homeroom, if you look at the table and you follow your numbers as they go down the chart, you know, in linear, when we do our loop-d's, they add to give you the next one. But with exponential, you'll find they multiply by the same number over and over to give you your exponential. Okay? Now, what's cool about that is when you have a general form of an exponential, it's going to look like this. You're going to have a number, and then you're going to have another number to the exponent. This is in general. And so whatever number that you have inside being raised to the exponent, so whatever's with the x is your loop-d number. So in this case, my loop-d number is 2, so 2 would go inside the bubble. So I'd write y equals, and I'll put a 2 inside the bubble. And then the other thing is that this number right here is your y-intercept. So remember, y-intercept happens when x equals 0. So my y-intercept is going to be 1, so I'll put a 1 there. So this one is actually y equals 2 to the x when I simplify that down. So again, this right here is your y-intercept, and the number with the x is your loop-d number. Of course, loop-d is not really a technical term, so we could look at that more as being our multiplier. What are we multiplying by to get to the next thing every single time? So let's look at another example. Let's say we have a table that says 0, 1, 2, and 3, and now I have 4, 12, 36, and 108. So remember, my equation is y equals a times b to the x. And so a, remember, is my y-intercept. So my y-intercept is when x equals 0, that's going to be 4. And then the number to the x power is my loop-d number. So if I look at this, I'm multiplying by 3 every time to get to my next one. So that means the number inside the bubble is 3. Okay, what else can we tell from a function? Try that again. So the other thing about an exponential function is the graph of it. So let's talk about the graph of an exponential function. There's a lot of stuff that we need to talk about here. First off, in your equation, I'm just going to keep b to the x and I'm going to leave the a out of it for now. Whatever that b value is really, really important. So we could look at b as being a big number. Let's say y equals, I know this is weird to say, but 2 to the x is our big number. Okay, so then if I look at my table for that, I'm going to have when x is 0, and anything to the 0 power is 1. So then if I look at my graph, when x is 0, y is 1. And then let's say I plug in a 1, so that gives me 2 to the 1, which is just 2. And then let's say I plug in 2, that gives me 2 squared, which is 4. I could do 3, that would give me 2 cubed, that's 8. Okay, and so you'll see that this goes up, and then it goes up and up and up and up, and it's going to go pretty fast there. Okay. On the other side, I can plug in my negative numbers. So if I plug in -1, don't forget what a negative exponent does. 2 to the -1, that moves it to the bottom, so I really have 1/2. And if I go with -2, that means 2 to the -2, that 2 squared is 4, but I put that on the bottom, so I really get 1/4. And what will happen is as I keep on doing that, 2 to the -3rd, that gives me 1/8. And I could keep on going. It's be 1/16 and 1/32. And so what's going to happen is it's going to get smaller and smaller. But the thing is, it's never actually going to reach the x-axis. Okay, I get really close to the x-axis, but there's no way by moving a 1 over 2 to some power, there's no way to make this whole thing equal to 0. It can get really, really small, but it can't equal 0. So what you'll see is that if I have a big number for x, a big number for x, the path of my exponential is that it's going to hug the x-axis here on the left side, but then as it goes and gets to the positive side, it's going to get really, really big. And if you've ever heard somebody say that something grows exponentially, that's what they mean, that it just grows and all of a sudden it just gets huge all of a sudden, just tons and tons. Now, what about a negative, or not a negative, sorry, what about a b that's not? So when we say that a b is not big, we're talking about a b value that is between 1 and 0, not including 1 and 0, but between 1 and 0. Okay, so I'm thinking of things like 1/2. So maybe we're going to look at y equals 1/2 to the x. So we can make our table. We can start at 0. Anything to the 0 power is just 1. So then I can graph that. And then if I go to 1, I'm talking about 1/2 to the 1, which is just going to be 1/2. And if I try 2, that means I apply the square to the top and the square to the bottom, and I get 1/4. And let's say I go with a 3. Whoops, that's supposed to be a 2. And this is supposed to be a 3. Then I apply it to the top, I get a 1. And I apply it to the bottom, I get an 8. So now I've got 1/8. And so you'll see that all of a sudden now it's on this side that I'm getting smaller and smaller and smaller, but I'm never actually getting to the x-axis. I just get really close. But then if I go on to the negative side, now, all of a sudden, remember a negative exponent flips a fraction. So if I have 1/2 to the negative 1, I'm going to flip that fraction over, and now it's to the positive 1. So now I just get 2. And then if I take 1/2 to the negative 2, I flip that fraction over, and now it's to just the positive 2, so I get 4. And you can see the pattern. If I do 1/2 to the negative 3, I flip that fraction over, and now it's to the positive 3, I get 8. And now it's getting really big on the left-hand side. So now you'll see that if you have a small b value, meaning between 0 and 1, the general look of it is that it's really big on this side, but then as you go to the right, it gets really, really small and hugs the x-axis. Now there's a word that we haven't talked about yet, and that would be the asymptote. Asymptote is just the name of a line, so here it would be the y or the x-axis, where the graph gets really, really close, but it never actually touches it. And the idea is that it keeps on getting closer and closer until to our visual eye we can't tell that it's not on the line. But if you were to get out a microscope, or if you were to drill into it and get closer and closer, you would see that it's still above it, just a little bit. Or if it's from the bottom, it would be just below it, just a little bit. Every time you get closer and closer, you see it's still not touching. And that line, this x-axis here, is called an asymptote. So you'll see when you have an exponential function is that you'll always have an asymptote, and you'll have to look at what is your y-intercept, and a lot of times your y-intercept is just going to be 1 because anything to the 0 power is 1. The only time it's not going to be 1 is if I have a number in front, because then this would be 1 and then it'd be times that number in front, so you'd get a different number like 2 or something. So you're going to look at that. Now the other thing is b is never going to be equal to 1, and it's never going to be equal to 0. Also, b is never going to be negative. And the reason for that is because if b was 1, it'd be 1 to the x, or 1 to the 1, 1 to the 2, 1 to the 3, and they'd all be 1. They'd equal 1 every time, and so you just have a graph that goes across. It's not going to be very interesting. Also, if you have a 0, same thing. You're just going to have a graph at 0 going across. 0 to anything is just 0. And then if you had negative, remember, if you square a negative, it becomes positive. If you cube a negative, it stays negative. If you quadruple a negative, it becomes positive. And so all of a sudden, we're going to have points above and points below, and it's going to oscillate between the two, and it's not going to give you this curve that we're used to. So, last thing. If you ever have to graph an exponential, so let's say I had to graph 3 times 1/4 to the x. then what I would suggest first is making a table with your 0, your 1, your 2, your 3, your -1, your -2, your -3. Make the table. And then actually just go through the work of doing the math. So then this would be 3 times 1, which would just be 3. And then you can graph your point. So when x is 0, y is 3. And keep on going with that. There's no reason you can't just plug in points and work it out. So then this would be 3 times 1/4, so this would be 3/4. And you keep on going that way, and you'll see you still get the general shape. It's still going to go down and hug the x-axis, and I know it's going to do that because that was between 0 and 1, so it's going to be going down and hugging down here. And then on this side, it's going to go up really, really fast. Okay, and so you're still going to get the general shape that looks like this. It's just how fast is it going? Is it going fast or is it going slow? So that would be it.